So the first thing we have to do is put all the numbers in order. Then we find the center. If there isn't a number in the center, because there's two, then we find their average and our center becomes the median. Then we find the center of each half. That goes here. Give me a second. And then we need to know our max and our min. Okay. What this breaks our data up into a 5-number summary. And we're going to plot this 5-number summary and we're going to see what that tells us. So we have a 5-number summary, and this right here, quarter 1, is the median of the lower half. No, it's the median of the lower half. This is the median of the upper half.
The lower half is made by the median, right?
Your 5-number summary gives us 5 numbers. It gives us the low and the high. It gives us the median of the data, and it gives us the middle of each half. The median divides the data into half. We get the middle of the lower half, the middle of the upper half. And what that does is it gives us quartiles. If you think about sometimes when high schools rank their kids, they'll have the upper quartile, third quartile, the lower quartile. What we're doing is breaking the data up into quartiles. Let's sketch it and see what that looks like. I need to plot these numbers. So it starts with 27. I'm going to start with 20, and I'm going to number by tens. So we need a scale. And then I'm going to put a little mark on my, don't draw anything in yet. Let's just put a little mark where each of these numbers is. So I'm going to put 27 and I'm going to put 114. And I'm going to put 44 and 48. Those are very close together, and 68. I'll actually make this one red.
I'm not sure.
Then what we do is draw a box around these 3 inner lines. That forms a box. You're going to see these called box and whisker plots. And then I draw a whisker out to that line. Okay, so this divides us into 4 quarters, 2 whiskers and a box. So there's quarter 1, quarter 2, quarter 3, and quarter 4. We're putting how many numbers fit in that box. It's not telling us exactly where they are in here. I can just see the borders. I don't know what the numbers are in here. They might all be hundreds. They might be 75s. I don't know. Now, of course, I can look up here, but the box itself doesn't tell you that. Okay. So how do we interpret this plot? So if you remember last time, we said that shape was very important. We also want to know if there's outliers. We also want to know what the center is. And we want to know the spread. These are all vocabulary words we use. Here, I'll zoom in, that we use with our histograms. We're going to look at those with the box plot. So right now, can you tell what the shape is? The shape would either be symmetrical, skewed left, or skewed right. The tail is bigger on the right, so we're going to say the graph is skewed right. Now, it is important to write complete sentences. I won't make you do a million of these in your homework, but we want to be diligent on our notes so we get used to what statistics sentences look like. Outliers, I'm going to talk about in a second. You're not sure about those yet. The center, in this case, are we using the mean or the median? Median. So we say the center. Whoops. Oh, no. The center is the median. It is, what is it, 48? Yeah, because we can match it from up there. The spread. What does spread mean to you? I know, right? It makes me think of a sandwich. But it's the high minus the low, right? The range. You can think about range. So it's 114 minus 27, which equals 87. So the spread is 87. Now there's another range in a box plot, and it's called, this is range 1, top minus bottom. We also have an IQR. And you can write the words IQR. You don't have to write it out, but you should know it stands for the interquartile range. And that's easy, right? We would just take Q3 minus Q1. So 68 minus 44 equals 24. So we could say the IQR is 24. And it's okay to use the IQR as an abbreviation. You won't see me write out interquartile range. So we'll look at what this interquartile range does. It allows us to figure out our outliers. Now you can't just take a graph, like when you guys look at these numbers, you're probably thinking, I think 114 is going to be an outlier. That's too big. But we can't just say that. We have to mathematically show, and there's a mathematical formula for that. So the mathematical formula to find an outlier is simply Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. If numbers fall outside of the numbers we get here, then it's going to be an outlier. This is a formula that you want to write down and highlight and say, okay, I'm going to need to know that. That's how I identify outliers. We can't just identify them with, looking at a data set. We've got to be able to say mathematically, how do you show an outlier? So let's see if this data has an outlier. So we'll take Q1, which is 44, minus 1.5 times the IQR, which we calculated to be 24. Then here we'll take Q3 plus 1.5 times the IQR. So key those in, you can use a calculator, and let's see what our numbers are. Remember, you may bring your calculator every day and you may always use it. So 1.5 times 24 is what, 36? 44 minus 36 is 8. Let's calculate this one. 1.5 times 24 is 36. So this would be 68 plus 86. No, 68 plus 36. I'm adding in my head. Which is what these numbers mean to you is that a number less than 8 or numbers less than 8 and numbers greater than 104 are outliers. So we can exactly figure it out. We don't have to just look at the graph and say, oh, I think that one's too big. So as you go look at the numbers, do you have anything less than 8? So we do not have an outlier over here. Do you have anything greater than 104? Do you have anything greater than 104? Yes. So this little guy is an outlier. That means he's, well, let's see. There is an outlier at 114. This is an unusual feature. We're interested in outliers. We want to know where they came from. Why are they out there? Is it a mistake? Did I type the data in wrong? Or is there something really that far out? Once we have our outlier, we're going to redraw our plot and we're going to put the outlier out there. So this time, we're going to keep all these numbers the same, except for our maximum with our whisker on this side. Instead of using 114, we're going to use 82. We're going to pretend that 114 isn't there. So we're going to re-sketch this. So let's remake our scale. Okay, so I still have 27. I still have 44, 48. I still have 68. But instead of 114, I'm going to go to 82. We still put a box around the center 3. Then we put our whiskers on. So now we can't ignore the fact that there's an outlier. We can't just kick it off. So what we do is we put it as a dot out here to show that there is an outlier. Right? This is an adjusted box plot. We don't redo any of the numbers. We just kick the outlier off and put it on as a dot. Now, if you look at this, it's more symmetrical and we might have a better picture of the data, right? I'm going to take a little break from your notes for a second, and I want to make sure that you understand the difference between a median and a mean and what they do. So let's go down here and we'll say that someone in our class got their grades back. Maybe it was Hutton, I'm not sure. But these are the grades this student has. Obviously, I'm making these up. Here are the grades one of my students has. These are the grades. Now let's look at these. What's the median of these numbers? Right? 3 and 3. So this is the median. Now average those up with your calculator and tell me what the mean is. I don't want you to think this is part of that, but I need to make sure that you understand. So find the mean, add them up and divide by 7. Did you add all 7 up and divide by 7? Did it go that low? Let me. Okay, so the mean is 85. The median is 96. Now, let's talk about a couple of things. If this was someone's grade and I said, you know, why don't you come in and make that up to a 70? And you come in and make this up to a 70, would it change the median?
Yeah.
No. Would it change the mean? So tell me a major difference between a median and a mean. Yes, the mean is the average. This is the middle number. Which one of them is affected more by outliers? The mean. So something we can pick up. Now, if you were to look at this, you're pretty much guessing 15 is an outlier, correct? Yeah. So this would skew it to the left. So notice When data is skewed to the left, it brings the mean down. What do you think happens if data is skewed to the right? It brings the mean up. What happens to the median? Nothing. So the median is a great measure if you have outliers, because it's steadfast and true. It doesn't get swayed, right? Which one do you think is a better description of this student? An 85 kind of kid or a 96 kind of kid? 96. Obviously, something was wrong this day. Turns out they bubbled their sheet wrong and they had one blank dot and it was all off a dot, right? So this is interesting and we want to look at it. I'm going to pull this test up and say, what happened? And then I'm like, oh, off a dot. You skipped number 3 and did all your ABCs because you did them in a booklet and then you filled in dots. We would look to see that something's wrong, but it's a big, important deal because you guys are probably used to always looking at the mean. How many of you actually ever pull a median up? You don't, because you don't really get how to use it. Now you're starting to see, okay, if there's an outlier, I want to convince everyone I'm a good student. You can say, oh, my median's 96. You don't want to tell them your average is 85, right? So the median is very useful, especially when we have outliers, because we want to know the truth, right? What's the point of this data? It's to tell the truth about what we're looking at. And this is a better description than this. Something weird happened here. We had that crazy outlier, okay? So we're going to practice together. I know you can build a box plot. That's not the hard part. The hard part is being able to read it. So we're going to practice a little, and I'm going to help you learn how to write your sentences in a statistics format. I know you're all good sentence writers, but you're not used to math sentences. So let's look. First of all, we don't know what this is, but I want to make sure you can identify the parts from a box plot. So this is the max. This is the min. Do we all agree on that? Okay. And this is, right, this is Q1, Q2, but we don't ever write Q2. What do we write? Median. This is Q3, right? This starts the upper quartile. Right? This would be the lower quartile, right? I don't have room to write. Now, this isn't telling us what the values are. That's telling us where they're spread out in the top quartile, right? 1, 2, 3, and 4, right? How do quartiles divide the data? We need to answer, how do you answer a scientific statement, like from chemistry and stuff? You repeat this, right? You basically rewrite the question and put an answer on it. So we say the quartiles. We're not going to write a million, I promise. And we'll get computers soon. The quartiles divide the data, right, into fourths or quarters. So remember what we're doing. We're taking all the little list of numbers of data and we're just separating it into 4 even pieces, like 10, 10, 10, and 10 numbers, or 4, 4, 4, and 4. We're not saying, oh, I want all the 90s here. We're not doing that. We're cutting it up into 4 equal parts. If I took you guys, 28 kids, I could do 7 in each quartile, couldn't I? What is the range of the middle 50% of the data, the IQR? Okay, on this one. So how do we answer this? We take off the what is and we rewrite it. So we say the range of the middle 50%, 50% of the data, IQR, is, what is it? What numbers would you use? 40 minus, I don't know, that looks close to half. I'm gonna say about 14, 13 or 14, whatever you pick, right? You have to make a little bit of a judgment call because there's room in between those numbers. What is the range for the lower 75%? What parts are the lower 75%? That would be 1, 2, 3, right? Those are the lower 75%. So what is that range? It's going to be what? 40 minus 10? Yes, these edges mark the points where it changes. So the range for the lower 75% of the data is 30. What is the shape of this box plot? Is it symmetric? Is it skewed left or is it skewed right? It's got a tail on the right. It's the whisker is longer on the right. So we would say it's skewed right. So how do we answer? The shape. See how good you are answering these? Is skewed right. And what's on the right side? Lower numbers or higher? So we could say right toward the larger values. We don't, because the right whisker is longer than the left whisker on the whiskers. Yes, it depends on the length of your whisker. We don't have any context with this problem. We don't know if those are grades or what they are. If they were grades, we could say towards the higher grades or whatever we see. We just have to call them values because they didn't tell us. Does the box plot display any outliers? Does it? Yes. But we have to show the work. How do we find, now this outliers on the right, and how do we find that? Q3 plus 1.5 times the IQR, right? So what's Q3? 40 plus 1.5 times, what's our IQR? 40 minus 14. 13 if you put 13 there, it doesn't matter. So we know anything bigger than 79, we can see that is, so we can say the box plot, right, shows one outlier. At, I don't know, 91. And we would also want to say values greater than 79 are outliers. When someone reads your answer, they should be crystal clear on what's going on. Remember, you're the statistician. You're turning this into your board of directors so that they can make some informed decisions. So you've got to be very clear. How do you expect the value of the mean to compare to the value of the median? Would the mean be the same, higher or lower? Higher, because it's skewed to the right. So it says, how do you expect? So I would say, I expect the mean value to be greater than the median value. Why? Because the box plot is skewed right. Skewed right where? Toward the larger values. Don't we sound fancy with these fancy big sentences in math class, right? So we would expect the mean value to be greater than the median value because the box plot is skewed right towards the larger values. One of the things we'll get to in statistics is you want to be as specific as you can. You want to be very clear in your communications. Statistics is a way to communicate, right? What's going on in the data. You have to assume whoever's going to read it isn't that great at statistics. So you want to tell them you're the expert, right? So now we'll practice one together, and I typed up the sentences so you don't have to write them because I know you're tired of writing sentences by now. Okay. So y'all take a second, and I gave you some data on different cars, specifically Japanese car and American cars. I gave you two box plots scaled the same way, and here's the data. So you can maybe answer the question. So let's take a second and see if you can answer those. Okay, so the approximate median weight of an American vehicle is 4,200. That's good. If you wrote 43, that's okay, or 4,150 or 4,250, you're estimating. Which is what? Lighter or heavier than heavier than the Japanese, than the approximate median weight of the Japanese vehicles of about 3,300, you said? And that's right, because you're looking at these, right? So let's see if we can navigate through the rest of these questions, and then we'll be done. Compare the spread of the data shown in the box plot. The middle 50% of the Japanese vehicles lie between approximately what numbers?
4,000.
So I would say that that may be what? Yeah, maybe 2,800. And where's the other? Yeah, I think that's pretty close, maybe. So if you put 2,800 and 41 or 4,050, anything close to that, because you're estimating, you can't tell for sure. Compared to the middle 50% of American vehicles that are between what? What do you think it is, like 33, 34, and 48?
Are we supposed to be looking at the actual data?
No, you're supposed to read the box plot. So what would that be between? Maybe 33, 48? Pretty close. We see that what percent of Japanese vehicles weigh less than all American? Well, it's this much right here. When that's how much? 25. Each one of these areas is 25% of the data. So, okay, both the what box plots? Well, what are the two box plots we have? American and Japanese. And again, I made these fill in the blanks so you didn't have to write all your sentences out. I would not format a test this way. That's too scary, right? Appear to be slightly what towards which way? Skewed toward the, are they lighter or heavier vehicles on the right? So toward the heavier vehicles, right? So they're skewed to the right. For both American and Japanese vehicles, the blank 25% of the vehicles has a larger range than the upper, than the lower. Let's look at that. The upper, do you agree that here's the upper? Does it look bigger than the lower? It does, right? So we have the data points are spread out. There is one what vehicle that weighs noticeably more than all others? American. And what do we call that guy? Outlier. Just so you know. Now, one thing we want to point out is what information can be gained from the table that's not available on the box plot. There's a couple that I want you to notice. Yes, the exact number of vehicles we could count. What about the mean? We can't get that from a box plot, but we could get it from a table, right? All right, we're done.